Okay, all right, everyone. So welcome to the experiment 3, oscilloscope. So in last experiment, you already studied about how to generate the AC signal. So in today's lab, you are going to use oscilloscope to detect the AC signal. So I'm not going to read through those this lab menu. You should already check this before you come into the lab. One thing you need to pay attention is some of the term in here is used for the benchtop equipment in the classroom or the lab room. For example, in here, the auto scale is called AutoSat in ECE2, and also the normal mode is called shift mode. Normal mode is the repeated mode, and the rule mode is called shift in the ECE2. Okay, so let's directly go to the tasks you're going to do for today's lab. So generally there are 4 tasks. The first 3 tasks are kind of similar. So for example, the first one, you are going to generate this signal in the wavegain, and then you measure it by connecting 1 plus to W1. And also in here, you need to press the auto set. Okay, so auto set in your ECE2 is you click this little arrow and then click the auto set. Okay, that's where you can check the auto set. And then in question or step 4 and step 5, we're going to adjust the horizontal scale and the vertical scale. So what are those two is, so for example, this is your ECE2 screen. So you can see the x-axis or the horizontal scale, that's the time scale. So, and then the y-axis, which is a vertical scale, which is the vertical scale, and that is the voltage scale. And you can change it. You can change the horizontal scale, the time scale, by changing this number. Okay, if I screw my mouse, or I can change the number in here. Or I can also change my vertical scale, which is the voltage scale. Okay, I can want like, so like per division, I can set it to 1 volt. Okay, because this amplitude is 1 volt, or if I can change to 2 volt. Okay, so the amplitude will be 2 volt, and each division is 1 volt. And also I can change my time period. And in that case, you can check the period. And also, let's see, in step 6, okay, you're going to use cursor. So that's what I mentioned. You can find X cursor or Y cursor in here. So X cursor is using to measure the period. Okay, for example, I put the first line here and the second line here. So the difference, the time difference from here to here, that's 1 period. And then this is a time difference. And you can measure or you can calculate the frequency by 1 over this value. That's the frequency. And similarly, you can use Y cursor to measure the amplitude. So I put this at top of my signal, put this line at bottom of my signal, and I can check the difference. Okay, so this is the difference. And this value is the VPP, so which is peak to peak. And then the amplitude is half of this, okay? So this should be, amplitude should be about 2 volt, which is exactly what you set. And then in task 2, you're going to generate a triangle wave. Okay, so you can set the triangle wave in here, set this to triangle wave. And also you will need to check the ground echo. Okay, so in your scoop, this is the ground echo. Okay, you can move this to move your signal go up or go down. So this little triangle, and this little triangle, the right one is trigger. Okay, you're not going to use this this thing in this lab, but you will use this in next lab. Okay, so just remember this is your ground echo. You want to show this in your screen. And then in step 5, we are going to use a measurement tool. Okay, so some reason I cannot click here. So here it should be your measurement tool. Let me delete this one. Okay, I don't know. For some reason I cannot run the measurement, but you can just click here to. I think because I'm in the demo mode, so I cannot run the measurement. But you should able to click here to measure the voltage or the amplitude or the frequency. Okay, there are some defined measurement. You can just click here. Okay, that's step number 5. And remember, you need to take the screenshot. And then in task 3, you're going to generate a sawtooth. Okay, how you can generate the sawtooth is you can use triangle wave and change this to 100. So you will have something like this. This is a sawtooth signal. And in here, it's mentioned increasing with time. What that means is if you check your signal, this is your time scale, and your signal is increasing with time. So that's called increasing with time. If you change this to 0, and then this means decreasing with time. Okay, so that's what's the meaning of this. And also you need to change to row mode, and where you can change this is you change this to shift. That's a row mode in the ECE2. All right, and that's the first 3 tasks. And then the task 4 is different. You need to generate to build a voltage divider circuit. It's in the figure 3.4, which is this figure. Okay. By the way, so this is a circuit diagram for the oscilloscope. Still, this is a benchtop equipment. The ECE2 is a little bit different, but similar with this one. So try to remember you have this diagram in here. All right, so let's see. So this is a circuit you're going to build. Okay, so it's 3.4. This is the equivalent circuit. And in here, in this task, you're going to use some component called potentiometer. Okay, so this thing. And this is like this in your lab kit. And what's inside this is something like this. Okay, so you have 3 pin A, pin B, and pin C. Okay, the middle pin is pin A. And pins A and pin C can be swapped because this component is symmetric. And what's inside this component is like a resistor strip. Okay, if I connect pin A to pin B, okay, so if I turn my little knob to most left side, and when there is current goes through pin A, and it will directly go out to pin B. That's like 0 resistance, okay, because it's not, the current not goes through your resistor strip. Or if I turn my little knob to most right side, if I current go from pin A, it will go through all the resistor strip like this, and then go back to pin B. In that case, your resistor will be like 10K ohm. Okay, so all the potentiometer in your lab kits, the maximum resistance is 10K ohm. Okay, so that's why when the current goes through all the resistor strip, that's like 10K. Or if you turn your little knob to the middle pin, the resistance is like 5K. Okay, so that's how these things work. And then you need to build this in your breadboard. Okay, so for example, I put this pin A, pin B, and pin C, A, B, C. And I have an input, which is from the W1, the AC input function generator, connect to pin A. And also, I want to check the pin A by using the oscilloscope, so I will connect 1 plus to pin A, and which is also connected to the W1. And the middle pin, pin B, is my output, which is connected to another channel, channel 2, which is 2 plus. And remember, when you connect 1 plus and 2 plus, you should always connect, most of the time, you should connect this to ground, okay? Because you are measuring the voltage difference from B to C and A to C. So these two, 1 minus and 2 minus should be ground. And also pin C, which is the last pin, should be also go to ground. So this is how you connect your circuit in the task 4. All right. So after you build this circuit, you should just tune your potentiometer, tune the little knob here, and you will see your output will be different. Okay, so that's all for today's live. Just email me if you have any questions.